So you may have noticed that recently I've just been a little talking head guy in a circle, hiding my space from everyone. Well, the time has finally come to reveal what I've been working on. Welcome to the new studio. This space is the result of 4 years of my own blood, sweat, and tears. I'm going to fully break down the thought process of creating this space, the various triumphs and numerous pitfalls during the construction, my expectations versus the realities, what I learned about acoustics, what audio technology I've employed in here, and loads of other stuff in case you're curious about upgrading your own space. Not only will this video be a reveal, but a super detailed answer to the question, is any of this really necessary? Like, do you actually need a state-of-the-art acoustically treated space to properly record, mix, and master music? And instead of making you sit through the whole video to answer the question, no, of course not. With today's modern tools, you can get a quality pair of headphones and a laptop and get great results. So the real question is, did I just waste years of my time and money and get conned into a Sweetwater credit card for no good reason? Let's talk about it. In this video, I'm going to discuss the various reasons why a space like this can either be completely unnecessary or, on the other hand, crucial to different types of musicians, producers, engineers, and so on. And in the process, I'm going to lay out tons of studio design tips and tricks that help me save time and money. This video is likely going to be a bit long, but my intention here is to, yes, entertain, but also inform you. I'm sure if you stick around for the whole thing, you're gonna learn something valuable, as this entire 4-year process was just one giant super lesson for me. So quick backstory. I've spent my whole life making music in dingy, much less than ideal places, mainly basements and tiny little bedrooms where the acoustic properties of the space were pretty bad. And what that means is like low ceilings, close walls, little to zero humidity control. Those of you who have been watching the channel since the early days may remember that one terrible basement space that I had with its laughable curtains, complete with washer and dryer. So needless to say, I've always wanted a dedicated space, and it's been a life goal of mine to someday at least be able to work out of one. It all started one day when I was down in our dirt crawl space of the present house that we live in. Our house was built on a really steep grade on the side of a mountain. So one side of the crawl space was only about 4 feet high, but due to the slope, the other side was nearly 15 feet tall. Thanks to my neighbor Bo and my other friend Nathan, who happened to be a structural engineer, they told me that we could do the unthinkable. And as crazy as it sounds, we actually decided to add another floor to my house by digging underneath it. Frankly, I didn't even know that this was possible. So we got to work. I was driving a little front loader and my neighbor was using a mini backhoe. It was pretty sketchy to say the least. I'd hate to think what would have happened if I had actually run the machine into one of those support posts. Probably one of the more nerve-wracking things that I've done. But eventually we dug the space out according to the plans that the structural engineer guy made. And in order to make the actual rooms, we needed to set the house on these huge steel beams. That way we could remove the support posts and have a clear span of space for the studio and the other rooms we were going to build. So after digging it all out and buying these really expensive beams and getting them installed, something happened to me that I was eventually going to find out would happen a lot more than just once. I ran out of money. It was really embarrassing too because I had to tell the contractors that were there to go home, and I would call them when I had more to invest. But I also quickly realized the advantages of building this space in my own home. I could break the project into phases and save up for each one of them individually. So even though I didn't have the money to do the whole thing, I could just do it piece by piece. I decided to spend the downtime researching acoustic treatment designs and try to wrap my head around the various options for my new space. Now I have a good amount of experience treating rooms. I've used that silly foam stuff, and then I've taken room measurements and learned how trash acoustic foam is, and then I learned about rigid insulation. And throughout the years, I've built many a bass trap with fiberglass, rock wool, and other materials. So quick side note, the reason I'm dogging on acoustic foam is not that it doesn't absorb sound. It does. Anyone who's had a raw room, then placed foam on the walls, and then did the seminal clap test will have a somewhat satisfying experience. It's not a question of whether it absorbs, it's a question of what it absorbs. There's a nerdy thing called absorption coefficients, which shows the relative amount of absorption each frequency range would get depending upon the material and the thickness. To avoid getting into the weeds here, foam tends to absorb top end and some mid-range, whereas materials like rigid fiberglass, rock wool, and pink bat insulation tend to absorb in a more broadband way, where frequencies that are common to human hearing are pretty much absorbed at a similar rate. The net result of using foam is not that it won't sound better in a room, but if you have a ton of foam in your studio, you'll wind up absorbing a lot of top end, which can make you want to mix your music bright or have too much treble content in the mix to compensate for what you're hearing. Meanwhile, you won't be able to absorb any frequencies below 500 Hz in any meaningful way, which makes foam, in my opinion, more trouble than it's worth. The general idea when applying acoustic treatment is that you want to try to absorb and diffuse sounds evenly across the frequency spectrum in order to get a good sense of the mix. More on this later. So even though I felt pretty confident that I could treat a room with bass traps and absorption, I knew deep down inside that my limited knowledge would only yield limited results. While it was fun to learn about bass trapping, and it certainly helped me treat many spaces that I've worked out of, acoustic science wasn't my main focus or my main area of expertise, and I wanted a state-of-the-art listening space. And meanwhile, in that same time period, another thing was about to happen that would change my life forever. We had our first kiddo, little baby Lyric. I was so stoked when he was born, and I'm blessed to say that I became a dad. And along with that, I realized that if I wanted to work with loudspeakers late night or early morning, or blast drums or blast guitar amps, maybe I needed to begin to explore the idea of isolation. I wanted to be able to close my studio door and be able to work with my loud and potentially baby nap ending sounds rattling and echoing through the house. And here comes another side note. So what's commonly referred to as soundproofing isn't specific enough for actual real-life acoustic applications. When we're talking about construction for acoustics, there are actually two separate areas of focus: acoustic treatment and isolation. So that's what I meant when I said I felt like I had a fair amount of experience in acoustically treating a room, acoustic treatment, but definitely not isolation. When it comes to isolation, I had zero experience, and that's when I decided I need to seek true expertise. So instead of going it alone, designing the room with my limited acoustic experience, I decided to take a step back and really try to honor the fact that this space was going to be my endgame studio. Enter veteran acoustician John Brandt. John is nothing short of a genius. He's designed studios all over the world for mixing legends. The spaces that he's designed are incredible, and I'm so happy that I discovered him. John offers a rad and unique service where you send him the dimensions that you're working with, and what the purpose of the studio is going to be, and whether the room is going to be just acoustically treated, or, like in my case, where you not only want acoustic treatment, but you also want isolation from the rest of the building and the environment. Now, his service isn't cheap. This guy might be the most knowledgeable acoustician alive, and his time and expertise is valuable. But, as I learned, it is far and away cheaper, by lots of zeros, than bringing in specialized contractors and specialized crews. So after months of saving money, I decided to go for it and buy into his service. The process was pretty simple. We just had a Zoom consult, and I told John what the studio was for, and I gave him the raw dimensions of the room. I knew where I wanted the room to be. Due to the slope of the house, the area with the highest ceiling clearance was where the slope of the mountain was the lowest. And again, in that corner, from the raw floor to the ceiling was about 15 feet. Side note, commonly the worst standing wave in a room is generated by the fact that the floor and the ceiling are the shortest distance from each other. All parallel walls in a room create standing waves. And here in the States, a very common ceiling height is 8 feet. An 8-foot-long waveform is around 141 hertz. So if you've ever looked at a frequency response measurement of your own room, and you had significant peaks and nulls around that area, congrats, that's the same problem everybody else has with an 8-foot-high or similarly low ceiling. Now, it's not like you can't treat a room with an 8-foot-tall ceiling, but a decent rule of thumb here is that the bigger the space, especially the higher the ceiling, the easier that space will commonly be to acoustically treat. But the trade-off, though, is that the bigger the space you have, the more space you have to cover with treatment, so that could get potentially more expensive. So anyway, I sent John the raw measurements of the space, and I told him that I wanted an isolated room that was acoustically treated to state-of-the-art levels. I'm not sure exactly what I was expecting, but after leafing through the huge plan set that I got, I quickly realized that in order to actually do right by this dream of having a state-of-the-art listening space, it was going to require a lot more time and energy than I originally thought. So after financially recovering again from the purchase of the plans, I called in the framers to begin framing out the space. In order to achieve good isolation, essentially the room that the music is being made in needs to be sonically and vibrationally isolated from the rest of the house, and of course the exterior walls. So how can you actually do that? Well, essentially this studio is a room inside of a room. There's the original exterior room, and then we framed out another room inside of it. The cavity between the walls was then filled with blown-in insulation. So I think we should also quickly talk about materials. Something that blew my mind about John's design was the lack of specialized materials in it. Nearly all the materials needed to do this job could be obtained at a big box hardware store like Home Depot or Lowe's. Now, you might be thinking exactly what I was, but hey, what about the floor? If both the interior room and the exterior walls share the same floor, won't they be vibrationally coupled? Well, it turns out that after asking John this, he said that since the floor, in this case a concrete slab footer, was the lowest part of the house, it was coupled to the ground. And apparently, earth ground is what he calls infinitely dampened, or in other words, won't transfer vibrations. Neat. And now I'm sure you're like, okay, but what about the ceiling? Well, this is some next level acoustic tech, which is deceptively simple. So of course, under my house, you've got the wooden floor joists that the posts were originally holding up. And in order to build a room within a room, you couldn't just have the studio ceiling vibrating the floors. That would defeat the isolation. So that's where these cool little devices come into play. They're basically hanging silemers. The top attaches to the floor joists from the floor above, but the bolt that comes out the bottom is suspended on absorbent rubber, effectively dampening any vibrations that would have otherwise rattled the upper floor. So essentially the ceiling, which is again 2 layers of insanely heavy 5/8 drywall, is floating on rubber-like material. So after having the isolation done and the drywall mounted, I decided to do something unconventional. I decided to go ahead and buy my dream speakers. I've always straight lusted after the Neumann KH420s. These speakers are the chef's kiss. I was extremely impressed when I first heard them, and even though they aren't the coolest looking speakers in the world, they certainly deliver the goods. They serve this interesting middle ground between so many things. They're a true midfield speaker. They can deliver serious low end without the need for a sub, and once I discovered one of my favorite artists in the world, Avantone Mixcube, swore by them too, that's when I knew I had to have them. Believe it or not, these speakers are still the single most expensive things in this studio. And of course, no one I really know has the kind of free cash to just go out and buy these speakers, so I did what any self-destructing, eagle-screaming American would do. I got a credit card. Now, I think this is as good of a time as any to point out something for those of you who might be like, this is cool and all, but I could never afford any of this. Well, the truth is, neither could I. Hence the credit card. But even more so, here's my car. It's rusty and it's from 1998. Priorities. Anyway, I had a wild experience with the shipping of the KH420s. I placed an order and basically spent the rest of the week obsessively tracking the FedEx number every 15 minutes. I had the speakers sent to a FedEx pickup location, and when I got to the packages themselves, they were super beat up. Anyway, of course, I opened the speakers as fast as I could, and I immediately discovered that one of the speakers was totally bashed in multiple places. Sweetwater was awesome, though, and immediately sent me another set. And if anyone from Neumann is watching this video, you have made, in my opinion, some of the best speakers in the world. Why on earth is your packaging so bad? I get that you're audio scientists, but you need to hire a packaging specialist because I can't be the first person that this has happened to. Now, I don't want you to get the wrong idea about Neumann as a company or these incredible speakers, which have a really rad trick under their sleeves, which was crucial to this room's design, and we'll get to that in just a bit. So anyway, I decided to have some fun and take my first acoustic measurements of the raw space. I wanted to have a reference as to how the room sounded raw, and then how it would ultimately improve with various stages of acoustic treatment. Okay, so what you're looking at right now is called Room EQ Wizard. We're going to talk more about this software later in the video, but essentially this is just a quick room measurement where I placed the KH420s, my raw speakers, on stands and a measurement microphone in the listening position, and just took a quick room measurement. You can see these gigantic peaks and nulls throughout the frequency response, and this is characteristic of any untreated room. You're always going to get this kind of thing when you got a raw room before you put any acoustic treatment in it. But I thought it would be fun to take a look at this, and then later in the video, we'll take a look at how it improves over time as I add various layers of acoustic treatment. Hey, so I wanted to record this video early so that you could hear my voice. You can hear that it's got a lot of decay time. There's a lot of boominess. There's a lot of reverb to it. And that's because as of right now, this room has not been treated at all with any acoustical absorption, diffraction, or diffusion. There's only just the bare drywall walls of the interior room of this studio. So yeah, I'm really stoked to listen to the playback of my voice later when I've actually completed this. Okay, so this is the exact same phone I was recording to before, and now you can hear that my voice sounds completely different now that the treatment layer is in. Pretty dramatic and awesome difference. This room sounds incredible. So the next step was to begin the acoustic treatment layer. This, of course, was the part of the plan that I was the most excited about. The first thing we did was put in the T-grid, the drop ceiling, like what you might find in an office building. The reason that this is a good format for acoustic treatment is that you can get these inexpensive acoustic tiles that absorb sound. Acoustic ceiling tiles have an NRC rating, or a noise reduction coefficient rating from 0 to 1. A tile with a 0.7 and up are considered good for audio applications. But the real kicker is that you can place insulation above and behind the tiles, increasing the ceiling's sound absorption by a lot. And believe it or not, John's plan just called for plain old Owens Corning pink batt insulation, which actually has great absorption. Essentially, placing this insulation up above the ceiling tiles transformed my ceiling into a giant absorber and a bass trap. So the acoustic treatment itself in this design is crazy, with its awesome absorbers, bass traps, diffusers, diffractors, and stuff. But after studying the plans and taking measurements of the work that had already been done, I realized that the framers who constructed this room were decent enough to build the walls, but in order to get the exacting measurements that the acoustic layer demanded on the plan, a carpenter wasn't enough. What I needed was a specialist, a woodworker. So whatever you might have heard about modern studios costing insane amounts of money is likely true. But I can also guarantee that the main cost of this isn't actually what you might think it is. I bet that most of the money spent in these spaces is on the skilled labor itself. When I priced out how much it would cost to hire a woodworker to build all of the acoustic treatment, all 3 separate quotes cost more than all of the materials and even cost more than the speakers and all of the gear that I was going to place in the studio. Essentially, it wasn't so much the per hour cost, it was instead the insane amount of time making all of this was going to take. The actual hard hours of woodworking that someone was going to have to put in. So yeah, there I was, at an extreme crossroad. I had spent years and thousands thus far on making this room to spec from this super expensive plan set, only to realize that I couldn't even dream of affording to actually have the studio built to completion. I spent the next few days kind of freaking out, honestly. I really wanted this dream to come true, but it was just plain going to cost entirely too much. So after a few days of complete discouragement, I reached out to my cousin Jeff, who had recently made a really nice coffee table, and I was asking him about how he built it. He told me that it was because he bought this relatively inexpensive table saw called a Delta T2. He was also extremely encouraging, and he told me that if I set my mind to learning how to woodwork, that I could totally do it, and that the bulk majority of what he had learned he got off of YouTube. And you all know about how I feel about YouTube University. So it just so happened that Lowe's was having a sale on the Delta T2, so I decided to take a chance on myself. Maybe I could learn how to woodwork. Now, I have a little bit of construction background. I used to be a laborer on a masonry crew, and I had a little bit of experience with various construction trades. But what actually followed would definitely change my life forever. I called another friend, Jacob, who's been so helpful as a mentor, and who's actually put a lot of time into helping me make this dream a reality. So shout out Jacob and shout out Jeff. Thank you guys for really helping me make this happen. He showed me how to use the table saw and how to be present and focused on safety. As a guitar player, as my main profession, and a pro mouse clicker, I like my fingers exactly where they are, thank you very much. So, I began the extremely flawed and blundering task of learning how to woodwork. I made mistakes. So many mistakes. I made bad cuts, I threw out whole entire projects, I wasted so much time. But after I bought the table saw, an expensive dowel jig, and a $100 Wen track saw, at least the labor on my part was free, and it was me and my time and my willingness to hold myself to a really high standard. If a certain piece I was making was out or too wide or not wide enough by more than like 1/8 of an inch, I threw it out and started over. It was sometimes painful to have hours of work ruined by a bad cut, but every day I was learning more and more. Eventually I would get it right, and piece by piece, over time, I learned how to stumble my way through learning how to woodwork. I began to truly love the process. I loved going down to Bee Tree Hardwoods here in Swannanoa, North Carolina, to select the rough cut lumber that I was going to use. So one huge takeaway that I would love to pass on is that for any project that you're doing that involves wood, lumber yards are where the good woods are. And especially in the case of hardwoods, it's always less expensive. Big box hardware store lumber quality is just so bad now, and what's worse, their wood is almost always more wet. Lumber yards will commonly also have a kiln, where they use the kiln to dry the wood, and even though it's still a good idea to let your wood acclimate to your house after you buy it, kiln-dried wood is just better in every single way. So probably needless to say, I definitely suffer from being way too interested in everything. I have to actively stop myself at the precipice of each new rabbit hole that presents itself in my life. But through woodworking, I discovered just how much I miss working with my hands. The amount of time that I spend sitting at a studio desk, or in a tour bus, or in a van, doing nothing active with my body, woodworking, just like hiking, has become part of me. I'm happy to report that I'm going to be woodworking for the rest of my life. It truly is that fulfilling for me. It's actually kind of comical. You can see my progression from being a total noob at the front of the studio, where I definitely was learning the ropes, to the back of the studio where the joints are much cleaner. But here's the thing. I've learned that instead of being embarrassed by my crappy or shoddy work, that not only can I fix these things later, but as corny as this sounds, each and every little mistake is uniquely mine. It's a story that I remember. It's something that no one else on the planet could understand. I put myself into this space in a way that few engineers can actually say that they have. So maybe my woodworking isn't as clean as other studio woodworking, but it's mine, and I love every single little blemish and imperfection. Now, since not everyone here cares about woodworking on an audio YouTube channel, let's go ahead and move on. So as promised, let's get back to the KH420. The reason that this was my speaker of choice was because of the genius design. Most active speakers, like your studio monitors, have the amp permanently attached to the speaker. On the 420s, however, you can actually detach the amp off the back. Now, why on earth would you want to do that? Well, part of John Brandt's design was that this room would feature flush-mounted speakers. Or in other words, instead of the speakers on stands or on the desk in front of the front wall, they're actually part of the wall itself. So why do this? Well, there are many advantages, but to try to avoid getting into the weeds, let me break down the key advantages. So treble, and to a lesser degree mid-range, is relatively easy to direct. You place your speakers in an equilateral triangle with your ears, and bam, decent stereo image. But the lower you go in frequency, bass sound tends to have less directivity, and instead radiates out from the speaker in a spherical fashion. So if your speakers are on stands or on your desk, the bass that goes direct to your ears is fine. But the bass that also bounces off the walls in all directions means that there's more to have to try to control and treat for. In John's design, I needed to create these insanely heavy speaker boxes to put the speakers in. The boxes he had me build had solid MDF and 2 layers of drywall in them. The idea here is that once you place the speaker inside of the box, because it's so dense, sound can only travel out the business end of the box, thus significantly lowering the radiating effect of all frequencies, including the bass. So placing the speakers inside of the front wall will mitigate one of the potential dimensions of bouncing waves, which could have otherwise caused peaks and nulls in the room's response. But what about heat, you might ask? Won't the speaker simply cook itself if the amp is trapped inside of a sealed box? Well, that's what's so neat about the KH420. You can simply take the amp off the back of the speaker, turn it around, and then mount it into the same wall that your speakers are mounted into. You just need one Ethernet cable and a speak-on cable to connect them through the back of the box. That way, you can still access the amp's controls and dial in the EQ. And frankly, I think that this setup is dead sexy. The next thing that I needed to build was the Cloud, and what we like to call the Waffle. I consider a good cloud absorber to be the difference between a workable room and one that just drives me nuts. John's design is incredible, and certainly does an excellent job of diffracting and absorbing the desk reflections and standing waves from the ceiling to the floor. But I gotta admit, this thing was scary to build. First of all, the cloud portion is huge. Rather than build it out of hardwood, I built it out of poplar to try to lower the weight. Remember, the ceiling that it's mounted to is hanging, and already has layers of drywall on it. The Cloud was the first real test of my woodworking, and it was a scary thing to finally hang. But thanks to a drywall lift and help, of course, from Jacob, we got it up there. Then came the legendary Waffle. This is an acoustic butterfly decoupler. Its job is to help remove desk reflections. But whatever energy and confidence that completing the Cloud gave me, this thing immediately crushed. It was so hard. I probably threw out half as many pieces of plywood as actually went into the finished piece. It was so above my woodworking level that I even considered having John Brandt's team build me one in Indonesia so I could ship it across the world to this place. And we actually looked into it, but of course we discovered that the cost of doing that would have been ridiculous. So push came to shove and I pushed through. I clamped a straight edge to a square onto the piece that I was cutting, and I used a palm router to create this thing, and I still can't believe to this day that I was able to do it. I really didn't have the right tools to make this thing, and I'm stoked that it all worked out. Making the Waffle really helped me get good with a palm router, which was a trial by fire. But we eventually got it mounted, and that completed the ceiling acoustic treatment. It was finally time to move on to the walls. So the treatment design has a balanced amount of absorption and diffusion. The room began with a bunch of OC705 rigid fiberglass. Now these traps really didn't have to look nice because they would have treatment in front of them. So I made all of those traps, and then I moved on to building the front wall. So on to wood choice and colors. I chose to use ambrosia or wormy maple for the main wood that I would build the studio out of. And as beautiful as it is, I wouldn't recommend it to a beginner. Even though soft wormy maple is easy on saw blades, it certainly lives up to its name. It twists and twirls, and it just isn't that rigid, so it needs to be braced everywhere. But man, the way that the dark features pop out is so unique and so beautiful and really awesome. Now, a word about the fabric for the bass traps. This stuff is called Guilford of Maine, which is an acoustic fabric designed specifically for acoustic projects. As much as it was great that I was able to use pretty common materials, this was one place that I didn't want to cheap out on. Now, I can see how some people would look at this space and think, dude, what the hell is this guy thinking on his color choices? Usually a space like this, if you were to go with a brighter wood like the ambrosia maple, you'd use a darker fabric for, contrast. Or vice versa, this lighter fabric choice should have had a darker wood paired with it, like rich mahogany. But here's the thing. I've been making music in dingy, dark basements and cruddy beer bleach smelling clubs for my whole music career. Also, I'm in a basement now. Only this room doesn't feel like a basement. In fact, in a way, it feels like I'm outside when I'm in here. Everything is so bright. The floor, the ceiling, the fabric, the finished wood. It makes me want to work, and I feel inspired and alive when I'm in here. And frankly, I've always liked the look of black hardware, so to me, that's the contrast, the gear. To each his own, So anyway, John Brandt's plan set service also comes with a bunch of links to various details of each treatment panel and type. His designs are modular, as in you build each acoustic panel and then you join them together to form a wall. You see a lot of studios where they're building the acoustic treatment right there inside of the studio as one giant long framing job. Now I can imagine that in some ways things might go faster if you do it this way, but that's what's so great about John's piecemeal style build plans. If you want to change something or you need to fix something about the treatment, you can easily remove that panel and do what you want. For example, the KH420 is a beast of a speaker, especially in the low end. But in the case that I someday want to add big subs, which, let's face it, I probably will if I ever recover from this financially, I can do it because I can take out the lower bass trap here and replace it with a flush mount sub box. All right, here I am in my super dirty shop at the moment, but the reason I'm in here is because I wanted to talk about boxes. Essentially, the core skill that you'll need to know outside of being decent at various types of saw work is building nice and square boxes, because all of these acoustic panels are essentially just fancy boxes. So left to my own devices, I'm terrible at getting things square, which is a core skill, of course, of box building. That's why I wound up spending the cash on what's called a dowel jig. All of John's plans use what's called dowel joinery, where the sides of whatever treatment panel are attached by using dowels and glue. This is super hard to do by hand and by sight, especially for a newbie like me. It essentially lines your drill up perfectly with where the hole goes so that you can get down to like a 30-second accuracy or even better if you're good with it. And if you're off by a little, you can always sand out the rest. Definitely recommend a nice dowel jig if you're going to get into building wood treatment. So anyway, I wrapped the room in all manner of John's awesome designs. I love the wood slat absorbers. They're really awesome looking and do a great job in the front. The bass traps are super effective and the diffusers are really cool looking. Finally, it was time for the big boy job, making the rear wall, which has a layer of absorption against the wall, but then has a total of 15 separate wood diffusers in front. It slices, it dices, and it absorbs. Diffusion in the back of a room is a great thing to do as it breaks up standing waves, but it also helps the room sound bigger and more natural. So quick side note. In general, if you only have absorption in a room and you make the room sound really dead, it's harder to get your mixes to translate to the real world. As in, you'll try to make your reverbs wetter and more dominant in the mix, and generally you'll make your mixes sound busier with more conflicts because you're trying to fill up space. Having some liveness to the room creates an authentic, real-world feel. In my opinion, good acoustic treatment doesn't mean a completely dead-sounding room. You see a lot of studio influencer people doing clap tests everywhere when they clap in an untreated room and then they treat their room with absorption and then they show how dead the clap is afterwards. Now, I know that this gets views and that's why studio influencers do it, but I think it leaves people with the wrong impression. You don't want a completely dead space. You want an even distribution of all frequencies. Reverb and ambience is literally a fact of life no matter where you are. Sound bounces off things, and we listen to music when sound is bouncing off things. So it's far and away better to work out of a room that is evenly diffuse, meaning that all the frequencies decay around the same rate, because literally nowhere in nature do we ever experience sound without some sort of ambience with it. All right, next let's talk about studio windows. The window here was never supposed to happen in this room. In fact, if you look at early pictures of the space, I had originally wanted windows in the front part of the studio. This was before I hit up John or had any idea what I was going to do. I thought it would be nice to be able to look out into the woods up here while I was working. But once I hit up John, he immediately shut that idea down. You see, any window in a design like this is going to be an acoustic sacrifice to some degree. But again, I didn't want to feel like I was working out of a dungeon. To me, light matters, vibe matters. So the compromise was this huge and wacky window off to the side. This thing was a wild undertaking, and in order to do this right, we had to build the window completely from scratch. You can see the exterior pane and the interior pane, both of which have super thick glass. The frames themselves are solid white oak, which I was to learn is probably the best rigid wood that you can work with. Making a window airtight is very serious business. You can see the exterior and interior frames were attached to their respective walls and the insulation between them. Per John's advice, I saved up all of my silica bags of various electronics that I had bought throughout the years, and I put them in a bag. When we installed the windows, I actually placed them underneath of the insulation between the two panes, so just in case any water gets in there, it can be absorbed by the little silica bags. The main thing to avoid is if moisture ever got into this window, it would fog up, and as John would say, the foggy window would become a permanent fixture in the studio. So I ended up having the wild idea that this window space was going to serve more than one purpose. Of course, it lets natural light in, but I also decided to make it my little songwriting corner and a corner for other projects, sort of like an alternative to my main desk, just switching things up a bit. So I got a bunch of my favorite pieces of wormy maple together, and I made a secondary desk over there. The view is also inspiring. In the winter, you can see the mountains, and in the summer, it's facing a bunch of beautiful flame azaleas. So anyway, I completed the room build where I installed additional corner trapping with maple plywood and more pink insulation behind it. I mounted the lights and I had an electrician run the whole thing. All the lights are RGB, which might sound expensive to you, but I went with the wildly inexpensive Chinese Govee brand, and all of this lighting together was less than $400, which honestly, if any of these fixtures break, the cost to replace it is super low. So needless to say, I ran out of money again, and I had to save. I really wanted to put together this insane desk design that John wanted me to build. It's wild. It's essentially a desk that's also a diffuser that he calls the Borg 2. But I decided maybe if someday I get my hands on a CNC machine that I would do it. But to save a little money in the near term, I bought this awesome kit desk from Trinity Designs, which is made out of inexpensive plywood. My previous desk had a very flat surface, and that's definitely not acoustically ideal. You feel that side note coming on? So let's talk about flat desks. I see a lot of studio setups where the desk surface is wide and flat. One would think that a musician with a lot of fun gear would want as much surface as possible to fit it all. The problem with this setup is that when you have a lot of flat surface, you're adding a lot of reflective area for the waves that come out of your speakers to bounce off of. So you hear the direct speaker sound, and then you hear the same sound again a few milliseconds later, and the overall effect is a smearing and a comb filtering of the audio. Even with this Trinity desk, which was more designed for near field sitting on the top, isn't perfectly ideal. Even though the reflections will be minimal and less than my last desk by a long shot, I will still eventually modify and angle the top surface of this desk back so the reflections don't make it to my ears. So if you're treating your room with expensive treatment and you're eyeballing expensive speakers, but you have a desk with a lot of flat surface, consider instead changing your desk up to something like this that has a slanted rack space or a smaller setup. This doesn't mean that you can't have a lot of gear either, it just means that the gear would better be placed beside you on the left or the right, well past where the direct speaker sound would bounce off of it. I intend on building out a synth rack and a guitar world on either side of me, well outside of where any early reflections would bounce directly into my ears. So the final boss of the studio build was the doors. One for the exterior wall and one for the room within a room. In order to create real isolation, you have to have it airtight. You also want the mass of the doors and windows to equal the mass of the walls. If you don't, then the sound you're trying to isolate will travel to the area with the least mass. And if you'll remember, these walls are thick. So it turns out, in order to make doors equal the mass of the walls, we had to fill them with play sand. This job was crazy. Not only were the completed interior and exterior doors just about 300 pounds each, when you're building these, you can't make one single mistake. Otherwise, you have to throw away something that's heavier than a large human and takes 3 people to lift. So after the build, we somehow got this thing mounted on these super heavy-duty hinges, and John's cool design has these adjustable door stops with seals, and underneath are these rad automatic door bottoms that push down when the door is closed to create a perfect airtight seal. The final step was to install these automatic door closers to keep pressure on the seals. I also think that they add that nice final professional looking touch. So with the build done, it was finally time to test what's called the STR, or the sound transmission loss, from sound coming from inside the studio to outside of it. So allow me to explain what these 2 meters are showing. They're both showing dBA, but the meter on my iPhone, which is a free app called the NEOSH SLM, or sound level meter, is showing a more instantaneous level, and this nice minimalist meter on the right called the OHR-1 is showing a more average level. We can see a staggering 50 decibel drop in SPL from when both doors are closed and sealed. Isolation mission accomplished. Okay, so as promised, here we are back in Room EQ Wizard, and we're presently looking at the original acoustic measurement that I took before there was any treatment or using the Trinnov system in this room. And so you can see just a crazy frequency response here. But let's do a drum roll. Here is the frequency response after the treatment and the Trinnov. Just an insane, dramatic difference in the overall frequency response of this room. Just crazy, right? Now, this is impressive, yes, but this does not tell the whole story. In fact, I don't think this is nearly as impressive as something I'm about to show you. Now, this is the waterfall graph. Now, what the waterfall graph shows us is another dimension of data, and really a crucial dimension of data. In fact, I feel like a frequency response chart is just not enough to understand what a room is doing. A waterfall graph is much better at this. What this is actually showing us is, of course, the SPL, and it's also showing us the frequency spectrum, right? But what it's also showing us is the decay time, okay? The decay time is the Z-axis, the one that's coming toward you and going away from you. Going back to our all SPL chart, yeah, this green line is definitely flatter than the blue line, right? But going back to the waterfall chart, if you really want to get impressed, look at the waterfall chart of the raw room. It's completely off the chart. You can see that the Z-axis here, there's so much room resonance in the original room, even up high, 200, above 200 hertz up here. Yeah, 230, there was a huge resonance there. There's a huge resonance here in 326. There is so much room resonance that it is off the chart. I actually would have to go up to my controls and choose a time range of probably like a whole second in order to encompass all of the, you can see up here, especially this one, whatever this was right here, just to encompass all of the bouncing waves in that room, right? And again, going back to the finished room, just so much more uniform. It's not just that in this measurement that we had really long decay times. It's that the decay times of different frequencies were much longer and much shorter, okay? Talk about having a trouble mixing. Mixing in a room like this is really hard to do. So of course you can use SonarWorks or just a simple EQ to get the frequency response of your room to look pretty flat. But this tells you nothing about the decay time of your room, okay? This raw room measurement versus this measurement here, I mean, it's just insane. Being able to mix out of a room where the decay times, okay, of all the frequencies are similar like this is gold. So needless to say, I am beyond grateful and beyond impressed at John's ability to design this room in a way where all the frequencies were well represented and decayed at a very similar rate. To get an acoustic measurement graph to look like this takes real experience. I'm so happy. And honestly, we're going to be able to tweak this room and we're going to make it even better than this. We're going to work even harder on some areas and make it as good as we can get it. Cool, so we can finally move into the actual technology and connectivity I used in this studio design. My interface is the center of everything. It's my beloved RME UFX3. Folks can argue all they want, but this is, in my opinion, the single best audio interface ever made. There are zero compromises on this thing. Everything runs perfectly, and I've had zero issues. But the main thing you buy an audio interface for is connectivity, and this thing has such a cool trick up its sleeve called MADI. This allows you to run up to 64 channels of input-output at whatever sample rate you want, all over the place using just 2 little coaxial cables. And this plays perfectly into something that John had me do very early in the build process, and that's run all of the power and audio connections through inexpensive PVC conduit running under the treatment layer. The reason that this is cool is that all music studios are in a constant state of flux. You're constantly wanting to change it up, do upgrades, buy different devices, and run different connectivity. So those 2 little coaxial cables are ran into the conduit and then over here to this thing called the RME 12 mic. This is an incredible 12-channel preamp. This thing can be controlled remotely, and of course the preamps are loud and super clean, but the real cool thing about it is that it's MADI compatible, so you can add 4 more of these things and have a blast, right? There's also a PVC conduit going from inside of this studio actually out to the adjacent room next to this one, which is a lot larger. And the reason I did that is that in the future, I intend on building that room out as a live room where I can record bands and larger projects. So of course there's a lot here, but the main thing that I want you to check out is this guy over here. This is called the Trinnov Nova. The Trinnov is essentially a computer in a single rack space that takes the signal from your interface that would normally go directly to your speakers and filters it through IRs that perform some very vital functions. I built this studio to John's specs, and the response without any correction is incredible and better than any room I've ever worked with. But the Nova takes it a step further. The Nova comes with a little mic that listens to the frequency response of the room and of course provides an EQ correction curve. Now this portion is similar to what you get when you use something like SonarWorks Sound ID or the ARC system. The difference here though is that the Trinnov also corrects the phase of each speaker element and each speaker in relation to the other. What does that mean? Well, essentially the speakers have crossovers in them to achieve the lows, mids, and highs coming out of the woofer, the mid-range driver, and the tweeter. All crossovers will cause some degree of phase shift when this is done. So in addition to the Trinnov's frequency response mic, it also has 3 other elements which can triangulate where you are in the room and generate data that will inform the machine on how to fix the phase response of your speakers. So if you've ever used SonarWorks or whatever, you've likely had a pleasant experience where the correction it provides sounds relatively flat, or at least flatter than it was before. But the experience with the Trinnov is like nothing I've ever experienced before. The main thing that I hear is this super tight transient response from the speakers. When it's off, it's still very good, but for lack of a better term, it's kind of sloppy or goopy. When the Trinnov is on, everything snaps into this super coherent stereo image, and I can literally hear the smallest changes in how a sound decays over time. So, of course, going with the logic of trying to create a state-of-the-art listening setup, the Trinnov takes the last remaining tiny bit of slop out of the room and creates the single best listening experience that I've ever had. I can't recommend the Trinnov box enough. And the funny thing is all of that said, it leads me to talk about this guy. I just love it. These little weird speakers are the great contradiction of huge Grammy-nominated studios. Why do people spend incredible amounts of time and money on studios just to put these horrible-sounding speakers in there? Well, this is an Avantone Mixcube, one of the worst speakers you'll ever listen to. Thanks to the RME ARC over here, I can quickly switch it on and switch back and forth between the main speakers in it by clicking this little button. So why is this inexpensive little speaker in between my beloved KH420s? Well, if you'll notice, it's just one speaker. It literally can't create any phase problems in the first place. Also, while it can't really make sub or sparkly treble, this little a-hole of a speaker plays perfect mid-range, and it's the audible equivalent to exposing yourself in public. If there are any mix issues in the mids, this speaker will tell you in a not-so-pleasant way. But the beauty of it is that if you can get your mix to sound passable on the Mixcube, it will be passable anywhere. And it's always nice to have a little bit of a mix sanity check when you use one of these little speakers. I would never release any music at all without making sure that I pass my Avantone Mono Mixcube test. Anybody that's making music should absolutely pick one up. They're incredible. I'm not endorsed by or benefit from the sale of Avantone Mixcubes. I just think they're really good speakers. So getting back to the Trinnov, I presented this box last for a reason. Any room correction, whether it's something as insane as a Trinnov or just as simple as SonarWorks, should be the very, very, very last thing that you do to get a room sounding good. The first thing isn't treatment either. It's not even getting new speakers. The very first thing that you should experiment with when you're dialing in a new listening room is the placement of your speakers, your desk, and you. And this, in contrast, is nearly free. The reason I say nearly is that I suggest anyone who wants to get a decent listening environment set up to get a cheap measurement mic and use software that's free called Room EQ Wizard. This free software can take acoustic measurements that take only seconds, and you can shift things around until the response is as flat as you can get it. And then once you've determined where the best sounding location is for you, your desk, and your speakers, you can then move on to treating the room for problem areas. And then after all that's dialed in, you can use corrective processing like SonarWorks to get the last of the issues out. Now, of course, this is a huge simplification of the process. And honestly, it leads me back to the original question, which I'm finally going to answer in detail. Why on earth would anyone do this crazy studio build that took years and years and years when there are now headphones that mimic speaker responses and eliminate nearly all of the acoustic issues that take thousands of dollars to address? Well, honestly, it comes down to the purpose of the room and the person that's working in them. For me, I've always preferred to work on speakers, and mainly it's because I love to mix loud. When I'm mixing, I'll commonly spend most of the time mixing around 75 to 85 dB. For me, mixing loud really helps me make good decisions, and rapidly. There's this thing called the Fletcher-Munson curve, which essentially shows that the human ear hears all frequencies at their flattest around 85 dB. And I can hear you thinking out loud right now, hey, I can turn my headphones up that loud. And yeah, you're right. Only something happens to specifically me where I just have a hard time using loud headphones. It kind of makes me feel dizzy. I don't know if it's just me, but at the end of the day, mixing loud on speakers is something that I can do for much longer, especially in a treated space. Now, I know that you see me on this channel constantly using headphones, but that's because I need to manage bleed from my DAW for whatever video that I'm working on. I much prefer speakers, and again, I don't have anything against headphones. It's just that I personally don't love using them the same way that I love using speakers. But there's also something else. Headphones don't move me. When you've got 80 dB plus of some heavy music or drums, it literally vibrates your body. I know the feeling that I'm after when I'm mixing on speakers. I know how my body feels. I know when the push or the pull of the bass is just right. There's a visceral thing that's hard to describe and so missed when it's gone. Now, does this mean you can't mix bass or drums with headphones? Of course not. In fact, I think more often than not, due to how bad most bedroom studios are, headphones are the optimal solution for mixing low end for most people. But that also leads me to the next point. I'm an instrumentalist and a vocalist. This room sounds good. You can record an instrument up close or far away, and instead of the far away recording being a problem, it instead becomes a mixing tactic. This room provides me with miking options that my old bedroom studio never could have done. Now, this last reason might be surprising coming from someone like me who's had a wild and super lucky long music career playing giant legendary venues like Red Rocks and huge music festivals like Bonnaroo and Electric Forest, who's toured everywhere and so on. To be honest with you, just as much as I'm a musician myself, I'm a huge music fan. I love listening to well-mixed and awesome music. Sure, I can work out of this room, but another reason that I wanted this space is because I'm a huge music fan. Have you ever heard the Philharmonic Orchestra play Holst's Jupiter at 85 dB? Or Nigel Godrich's insanely amazing work with Radiohead? Or Aphex Twin? And you listen to it and you thought to yourself, wow, I can hear so much in this mix that I couldn't hear before, that I actually would have personally made some different mixing decisions than Richard D. James. Not saying that I would make better decisions. In fact, I probably would make it worse. But the point is, I heard something that I wouldn't have done the same way. Like the amount of resolution and detail as a fan is incredible. It's not that headphones can't achieve this, and in some ways, headphones can reveal details that speakers struggle to reveal. But the way that I hear and hear is everything to me. As a fan of music, as someone who's obsessed with sounds, and yes, as someone who's tasked with teaching thousands of international audio students, this room is also a testament to my dedication to the craft. So, some closing thoughts here. If you're a musician who's mainly making production music, I recommend focusing on getting a great set of headphones and really learning them. There are EQ profiles on the internet, and there are even headphone products like Slate VSX which simulate rooms like this to give you a great experience. But if you're looking to build yourself something like this, and you're in it for life, and you're like me and you love speakers and you want to build something wild and amazing, I really think you ought to consider hiring John Brandt or some other expert to help you. Knowing some things about acoustics is fine, but having expertise and someone you can ask questions to as they come up is indispensable and truly rare. There's also a lot of misinformation out there to sift through. An expert knows what matters, and honestly, I bet that John at least paid for himself multiple times over with the time that he saved me and the know-how that he has. I also think it's worth pointing out that I am not sponsored by John and I get nothing from referring people to him. I just had a great experience and he made all of this possible for me. And so above all else, I hope that seeing this space and watching this video has inspired you. I just want you to know that I've spent over 2 decades mixing out of much less than ideal places and really just like seeing all these amazing spaces and being like, man, I wish that I could mix out of a place like that, and just really feeling like it was out of reach. Honestly, if you want to learn how to build a place like this, learn how to build. That is my main piece of advice here. I know it sounds funny to be like working on being an audio professional or working your way up toward a studio, but if you can build, it makes everything a lot more achievable. And so even though I did have a little bit of construction experience in my background, honestly, I really did end up learning woodworking from scratch, and it took me years. So a patient mindset, being able to make sacrifices in your life when it comes to the other things that you have so that you can focus all of your resources and energy on making something like this, it is achievable. So finally, if you want to support me and this channel and help me pay back this credit card, consider checking out my Ableton online courses, or potentially checking out my studio services that are offered down in the description. And if you like this kind of thing, like and subscribe and ring the bell to be notified when new videos are posted. This studio kind of represents a sea change for the channel. I'm excited to be bringing a whole lot more, maybe more broad-reaching kind of audio education to the YouTube community. I hope this video was enjoyable and that you learned something helpful. Thanks for watching, everybody. I'll see you next time.